In the previous classes, we did part creation, and I showed you how to do a 2D shape extruded into a 3D depth. So that was our extruded boss or base. Then I showed you how to do a 2D sketch and an axis of revolution, which was our revolved boss or base. Then we looked at sweep, which is a 2D sketch and some other profile to follow. And after that, we looked at the lofted boss or base, which is basically just filling up the material between sketches. Okay, so what we're going to do today is I'm going to show you how to do assemblies. So now that we've done the parts, once you've drawn the part, just file save, give it an appropriate name, and then save it. And then once you have your parts created, you can go make an assembly of the parts. So assembly says a 3D arrangement of parts and or other assemblies. So to make an assembly, you first need the parts. Right, so for today, we're going to do assembly. Click on assembly, and then you click on OK. Right, and now some random block pops up immediately. And you'll see at the top it says open. So basically, this is to start inserting components into your assembly. I'm just going to cancel this for now. So sometimes your SolidWorks does not pop that block up, and it's not a problem. All you need to do to get that block back is go to Assembly and then Insert Components. Once you click on that one, then that block pops up. If it still doesn't pop up, you can just click on Browse on the left-hand side. Okay, so then you go and look for the parts that you want to start to make the assembly. I want to make the assembly starting with, for example, the side plate. And then I click on Open. Now you'll see I get this plate that follows my mouse's pointer around. And basically, wherever I move it, if I click, it will place it there in my 3D volume. What you can also do, if you want to have that plate's axis system to line up with your global axis system, you can just go to the OK button on the side. So if you click OK, it will now line up that part with your global axis system. So if I now go and use my mouse and I try to drag that plate around, once I click and drag, it says the selected component is fixed, it cannot be moved. So basically what it does, the first part that you insert into an assembly is always fixed to the global axis system. Not permanently, you can change it if you want, but it helps to have one known reference point. So it takes the first component and just fixes it to the axis system. Meaning if you make an assembly, start with something that doesn't need to move. So if you have like a fan that has to be connected through a belt or something to a motor, then it doesn't help to start with the fan because everything is going to then rotate around the fan, which is kind of not the purpose of the fan. It can be changed, so don't worry too much, but usually it helps to start with the stationary components or the big components first. I'm just going to delete this one and show it again. Click on it, press delete. Right, so we click on Assembly, and then Insert Components. I browse for my component, and then I click on it and click on Open. So now I can either click to place it wherever I'm clicking, or I can click on OK to place it on the global axis system. I can also rotate it in any way I want. Right, okay. So there I've got my first component inserted into the assembly. What I'm going to do next is I'm going to add all of the other components, and then, like with playing Lego, you pour out all the blocks on the ground, and then you start building stuff. Well, you don't pour it out because it's not a liquid, but you throw it out on the ground. Insert components. I want to add a hook. So I click on hook and then click on open. Click to place the hook. I'm just going to add all of them quickly. Now with the bearing, I want to insert 2 of them. So what I can do is I can go insert component, click on bearing, click on OK, click to place, then insert components and do the whole thing again. Or what I can do is I can click on the keep visible icon. So click on that one. And then if you click to place, you get another option to click to place again. And this will continue until you're happy. And then you just click on the OK button. Right. Insert components. Let's do the shaft. Open. I want 3 of them. Then OK. I want 2 of the wheels. Click. Click. And OK. Right. Oh yes, I want another plate as well. Insert components, side plate, click. Okay, so now the question is, now that I've thrown all of the toys on the floor, how do I actually tell SolidWorks to assemble these things? I can try dragging it and leaving it there, but SolidWorks won't pick up that I'm trying to put it in the right place. So there's got to be a more precise way of doing this, and fortunately there is. And the way in which we do that is this paperclip icon that's called mate. So you click on mate, and this allows you to specify relations between components. So you can tell one component to be against another component, or to be concentric, or tangent, or basically anything that you want it to be. It can do against, that's coincident, parallel, perpendicular, tangent, concentric. You can force it to be immovable. You can specify distance, specify angle, and we'll do the advanced mates later. Now the nice thing with SolidWorks is it is kind of clever in understanding what it thinks you want it to do. So you don't have to tell it must be coincident or concentric. If you click on 2 circular things like that hole, click, and this shaft, click, then it automatically puts them concentric. Right, so what it did there is it put the one inside the other one. It won't automatically detect that components are interfering. But what the concentric now does for us is it means I can still move that component around. You can see I can drag all of the other components, just not the first one. All the other ones I can drag and move around wherever I like. This shaft I now specify to be concentric with the hole. So SolidWorks will allow me to move the shaft, but it will always keep that constraint that it has to be concentric. So I can move it through, but it won't go anything outside of the concentricity that I specified. So next what I can do, after I specified the concentricity, I can actually go and click on mate and tell this plane that's now highlighted in blue to always be against that plane. So now what SolidWorks did is it made sure that that circle of my shaft is always against the flat plane of the plate. Will it be able to move now? It is only able to rotate now. So it sees that it has to always be concentric and always be against, but it allows movement in any other dimension that is still available. So these are quite handy constraints to place on an assembly if you want to, for example, see the movement of when you rotate an engine's output shaft and see how all the internal components move when you rotate it. These constraints basically do just that. So let's put the bearings and the shafts in their places. So I click on mate. This one must be around that one. This one around that one. This one must touch that one. And that one must go through that one. Sorry, I clicked there by mistake. Okay. That one, oops, I clicked two places before I wanted to. So you can always go on the left-hand side of the screen there, select the one that you didn't really want to select, and just press delete. Now I'm able to move it somewhere else. That one must touch that one. I can even tell this little hole to line up with that one. So now they are concentric, meaning they line up with each other. So if I zoom out and view it directly from the side, I can now see through them. Right, let's do some more. I want this wheel to be around that bushing, this bushing, and that wheel. And I want the side of the bushing to be in line with the side of the wheel. And that side and this one be in line as well. I don't know if you remember when we did this assembly in class, we actually said that that cylindrical part has a length of 60 and the bushing had a length of 59. So to be technically correct, we actually need to place it nicely and evenly spaced from each side. So I can now go and instead of specifying that one and that one to be in line, I can go and specify a distance. So I can click on mate, click on distance. We want it to be 0.5 millimeters between that one and that one. So now it will always ensure that the 0.5 millimeter will remain true. If I move it to the other side, you'll notice it has the half millimeter gap that side already. Remember, I can't go and specify it on that side as well, because then it will over-constrain the assembly. Let's quickly do that, then you'll see what I mean. So let's do a mate of distance 0.5 from this plane to that one. And at the bottom here now it says no solution found. So if I click on OK, no solution found means I gave it more instructions than what it can actually do. You'll see also that my side plate and my shaft and my wheel have now turned brown. So that means they are over-constrained. So to fix that, I'm just going to go down to mates. Here are all the mates that I've just placed. And I'm just going to delete the last one I made, because that's when everything went sour. So delete that one. And now everybody's happy again. Right. let's do the same for this wheel. I want a distance 0.5 from that plane to that one, and then click on OK. Okay, it's pretty easy still, hey? Let's put the hook in its place. The hook has the same length as the shaft, so they actually have to be in line. And this one and that one. This one and that one. Okay, so this one can only move in and out now. So lastly, what I want to do is put that part against that one. Right, so next, the only components we still require would be the castle nuts. All right, so let's add them. Castle nut. Right. I want this plane to touch that one. That one must go around there. That one must touch that one. Cylindrical parts to make them concentric. So as you can see, this is pretty quick to do once you know what to do. Oh snap, my castle nut has gone missing. I don't know if you noticed what just happened. I did the concentric before I did the coincident, and then it moved my castle nut to the middle of my assembly. So to get it out, I'm going to have to hide these components. So to hide something, you simply click on it, and then that fifth option there is hide components. So there I can see my castle nut, and now all I need to do is just take it by its ear and move it out. Okay, but now my hook is gone. So to get the hook back, if I go to the left of the screen, you'll see all of my parts are yellow, except the hook is transparent. So you simply click on that one, normal left click, and then there's the show components option. Right, let's quickly line up all the nuts. I want to just change that coincident to be a parallel. So what the coincident did is it means they are in the same plane and parallel, but the parallel only means they can still rotate together. So this one parallel to that one. Yes. So you'll see sometimes the SolidWorks default chooses the one that you didn't really want it to do, so you can just change it afterwards. Or you can pick it beforehand. So now the cool thing, I set all of those planes to be parallel. So if I take one of the nuts and I move it, all 5 of the other ones will move with it. Okay, and we want the split pin to go through, so I want this one actually to be nice and vertical. So what I'm going to do is I'm going to tell this plane to be parallel to that plane. Mate, parallel this one to that one. Yes. Okay, so now if I try and move the nuts, they won't. So it just says the selected component is fully defined, it cannot be moved. Okay, any questions? Split pins. Let's put those ones in. Insert component, split pin, open. Right, so we're going to mate them as well. I want to mate that part into that one. Okay, I want it to face the other way, so you can always just click on Flip Mate Alignment. Okay, now if you want to be really fancy and get this one perfectly flat, then what you can do is you can use a parallel mate between that plane and the inside of the split pin. And now check how cool this was now. The castle nut, this one is parallel to the other one, which is parallel to the side of the plate. So the castle nut cannot rotate anymore. And the split pin is concentric with the hole in the shaft and parallel to that plane. So now the question is, can the shaft still rotate? The answer is no. So because the split pin is concentric to the hole, it means the shaft and the pin have to rotate together. But the pin cannot rotate in the castle nut because then the parallel constraint between those two faces would be broken. So now my shaft is completely fixed. Okay, I think you get the idea. Cool, any questions?